nutshell.
It only has a few errors.
Before I took the LPI
Version
level 1.
How'd it go?
I passed it.
Yeah!
I always scanned that.
Good for you.
You know,
101?
You know how much I stayed about 2 hours.
101 or 102 or both?
101.
101? Good for
I
you.
did a full level 1.
Where'd you take them at?
Southeast Linux Fest out in
Oh,
North Carolina.
yeah.
Awesome.
I'm gonna do them.
Yeah, I
I keep
was hoping
procrastinating,
to
so I'm gonna take
do
the
level 2 this month at another festival, but
Yeah.
I'm not going to make it out there. The rate they've got crap piled up for me at work.
They don't do it at Prometric anymore, so there's only one place in Omaha that does it.
Which is,
I always got to go to Lincoln to the Southeast community.
I'll tell you an irony about that later.
Yeah, it's a pain in the butt. I had a whole class. I taught a course over the summer of 9 people.
Well,
At the end, they wanted to take a certification test. Had to drive them all to Lincoln to take the damn cert test.
The company that does offer them now is the company I used to work for.
Who is that?
I don't want to mention names.
Oh, the testing center.
Yeah.
The
Yeah. Don't mention their names.
Yeah, come on.
Please
Oh.
don't mention their names. No,
I can say it's the one testing center that offers the LPI course
There you
in
go.
Omaha.
Just don't name them.
All right,
Nice
fair
try.
enough.
That's kind of how I feel about
Company
it.
shall not be named.
I can tell you some stories about this place, and you will cringe.
Oh, I just remembered.
That's
All right, I won't say
really,
it.
yes.
But they're under new management. Like 4 years ago, right? Did they get bought like 4 or 5 years ago?
No, that's no.
Well, I'm not going to know to
No,
avoid this
no, no.
place.
They are owned by a very large multinational corporation.
Oh, maybe we're not doing this. Whatever.
They're owned by Nabisco.
Beatrice.
RJ Reynolds one.
What is it, Walmart?
Yeah, we're taking your test. Walmart. That Sam's Club in the back.
Actually, you know, that part you did it.
You have to be a member before you can take
It's
the
at
test.
Staples. It's at Staples, back in the back room.
That would be awesome.
Welcome to the September
I believe it's September.
2012 Omaha Linux Users Group meeting. I am John Larson, a system engineer at the AIM Institute. Adam tonight is going to be speaking about bash shell scripting and some common Linux command line tools. Is there anybody who's new here? Is this your first time here? What's your
Welcome.
welcome?
Stand up and sing your high school fight song.
Yeah. So, John, Adam, Tom.
He knows me because he's my nephew.
He's your nephew. Oh, okay, awesome. Does your nephew have a name?
Sean.
Hey, Sean.
Sean.
Kevin. Tom.
Tom.
Sam.
Sam's dad.
Sam's dad.
Sam's dad.
Christopher.
Kelly.
Noel, George, and what?
Mike.
Yeah, that's great. Okay.
And Aaron and Chet, if they ever make it over from the bar.
Yes, if they ever make it over
Pulls
from the
Aaron
bar.
over there.
Yeah.
Yeah. So tonight we're trying a little thing a little bit different. We're not using
Yeah, tell them about this, John.
We're not using a laptop to stream.
Tell them about this thing.
I got what's known as a Servo Live Shell. It's this little thing on top of the camera,
I'll play Vanaway.
and that's essentially a streaming device. Hooks directly up to the camera and just shoots it right out. I don't need to use a laptop or anything.
It's got, what is this? This is Ethernet, obviously.
Ethernet, it's got Wi-Fi through a USB port. It's got HDMI in. It has composite in.
So you can hang any old like USB Wi-Fi dongle off this?
It has to be an RA link. I plugged into my Linux box this morning to check it.
Okay.
It's an RA 2800 chipset. So if I lose it, because it's one of those tiny nano receivers, I can try to find a replacement one. It came with
Otherwise, you just hardwire it.
Yep. And it runs for 3 hours on 3 AA batteries. And
Or you have it powered off the little
I have it
cell phone
powered off
adapter,
of a
right?
USB. It's a cell phone power adapter. I tested it this weekend. I streamed my brother's wedding to my family, and the batteries did last 3 hours as they had said.
With this little thing right here.
Yep.
Cool.
And it streams to Ustream.
It does. It works with Ustream, Niku, and Livestream.
Because it's Japanese.
Yeah.
How do you configure it?
A web browser. So like for the Wi-Fi portion of
Plus
it.
it has a little tiny LED over here that gives you status
Once you
updates.
sign up for your account on their site, when you want to do Wi-Fi, you put the SSID in on a web page, then you put the password, and you put generate, and then you plug your speaker output into the microphone output on the device, and you press play. And that's how it does the Wi-Fi password. It's through audio.
Awesome.
Isn't that
Yeah.
weird?
It's pretty cool. So even if you add it later on, like if you want to do another SSID, that's how you add it in. But it works pretty darn good. I mean, we would take it off of the tripod mount and just walk around the room and talk to people. I gave it to some high school girls to let them go around and talk to people. And they just walked around like this the entire time. My aunts were like, hold it still, because you know they kind of move faster than most people.
That is pretty cool. And the quality was great.
Yeah.
Of course, I mean, that's dependent on the camera, but still.
Yes, and streaming conditions too.
Yeah.
But we should be able to see the screen a lot better than we had previously. So
For the low, low price of?
it was $300.
Still though.
$289.
This whole thing together is under $1,000.
Yep.
And you've got live streaming capabilities, nice camera, external microphone, mount, with at least 3-hour battery life. And that's pretty amazing.
Yep.
Mm-hmm.
That's really pretty amazing.
So the battery I had for it was 3 hours for the camera, and then 3 hours for the shell streamer. So that was essentially, you've got 3 hours.
Like you said, it's just a micro USB to charge it, right? So anything you can get that'll
Well,
get
not-
power over.
The charger is the standard AA
Yeah.
battery charger. I mean, you could throw in throwaway batteries in there if you want,
Yeah.
but I'm just using rechargeable batteries.
Right, but it's just giving it 5 volts over micro USB. So any
Mhm.
device that does that, you can use charges. I mean, there's extended
Yeah.
batteries out there
Yeah.
that has that interface that you can
This
use
is the
to power
mini
that
USB
guy.
plug
The mini USB, not the micro.
versus
yeah.
the micro, and I'm sure there'll probably be a
It's the
new
old
version
school
of
one,
it.
yeah.
Yeah, at some point, or you can get an adapter. Those
Right.
adapters are all over the place. So, show and tell, done.
That's pretty cool.
So, any announcements? Let's see.
Any new knowledge, bro?
I haven't been able to keep up the last 3 weeks. I know that they're taking away the 2D portion of Wayland for, no, there's a 2D portion in Ubuntu is going away. You all have to run a 3D capable card to be able to run their desktop.
Really?
A Unity desktop, yeah.
Good thing I use my
That's Unity.
Mr. Thacker isn't here.
I was gonna say, where's Dave?
But then again, he's a big KDE user. He's not really
He's like Kubuntu.
and there's a new version of Ubuntu that's going to be unsupported by Canonical. That the tentative name is Nobuntu, G-N-O Ubuntu, which is GNOME, a GNOME flavor. So, because I think they're dropping their KDE support as well. So that'll all be community-based versions.
Interesting.
Good thing I use window maker.
I like the name.
Yeah, Nobuntu. Yeah.
No Ubuntu.
There is a version of Debian for the Raspberry Pi that has been put out that has all the binaries are compiled for the Raspberry Pi in all the libraries. So it's called Raspbian, and it's available on Raspberry Pi's website.
You keeping up with shipping on those devices?
Yeah,
Yeah. So I order one tomorrow. How long will it take before I get it?
probably 2 weeks.
Wow.
I
Depends
think.
on where you order.
Yeah. You should go to Element 14 or Newark.
I have 3 of them on order. Well, actually, I had 3 of them on order. MCM Electronics finally shipped me one I've got for you.
Hmm.
But I went to LI first, 12 weeks, then I went to Element 14, got impatient. Then I went to MCM and ordered it.
I thought you
They
only
had
get up
them.
through element 14.
Hmm.
And I was surprised that MCM had them, but
What's MCM?
MCM Electronics, it's just,
One of the verified distributors or whatever?
no. I went to
Huh.
Oh, just the parts
they just
reselling.
sell lots of
Oh, and I've
electronic
seen
components.
Okay.
I've seen like 3 or 4 more Android on a stick devices announced
Yeah.
in the past 2 months.
Android on a stick.
Yeah,
That makes
it's like the size of a flash drive that's Android.
Oh.
It plugs into
And
the
it connects through
port.
HDMI. The newer HDMI ports give not only video, but they actually provide power as well. So you can actually have a self-contained computer running on a device about yay big And since it's plugged into an HDMI port anyway, the output is whatever display has an HDMI input. Have you heard of the Roku little media player? It's a little set-top box about yay big that runs Linux, lets you do like Amazon and Netflix and whatever on your TV. Their newest version is literally it looks like a USB stick, but instead of USB, it plugs into HDMI.
Well, I know the OLUG is supposed to be about the size of a Rubik's Cube.
Yeah, but that's got to have online. I mean, that's got to have storage and other inputs and everything, right?
It has to have its
So-
own power source because it's gonna be.
Yeah, that's be a little too much for HDMI power, but yeah, still pretty small though. Right? That's an ARM-based device, isn't it? Do you remember? I would assume so.
I don't remember. I can look it up real quick.
I can't imagine it would be anything else being that small.
Okay. Ready to
All right,
start?
Sure.
I'm gonna run. Be right back.
All right, so what I'm going to talk about tonight is the Linux command line. Now, I've only got, what, 3 hours to talk? 3.5 hours?
No, we're plugged in.
No, I'm just kidding. So this isn't exactly an exhaustive overview of it, but hopefully it'll introduce you to kind of the basic concepts of it for some of you that may not be familiar with it, or some of you that maybe a little bit, but maybe have kind of some gaps in your knowledge. And hopefully it'll help you kind of think about how the computer sees you. Because that's really what we're talking about. We're talking about a shell. And the shell we're going to talk about tonight is Bash. Of course, everything in Linux, there's no definites in Linux, right? There's no, how do you do this? There's never one answer, right? What program do you use to do this? There's always X number of answers. Well, there is not just one shell in Linux. There's X number of shells. I don't even know how many there are. Bash is the default one. The born-again shell has been the default Linux shell for years and years and years. It's popular enough that it's actually made its way into the commercial Unixes as well. Since Solaris version 9, it's been the default shell. I don't know about any of the other commercial Unixes and their users. But what we're talking about is interfacing with the computer from the command line level, right? You've got two basic kinds of user interfaces that we're used to in the computing world. You've got the command line and you've got the graphical user interface. The GUI is the point-and-click, mouse-driven, or menu-driven one that we probably, I was going to say grew up with, but some of us may not have grown up with that. I didn't grow up with that. That we know, and the command line, you know, most operating systems have some sort of a command line interface. So that's what we're going to talk about tonight. Bash is your interface to your computer from the command line. So it does these three things. It is the interface in that it accepts commands from you, usually from a keyboard, although there are other ways as well. It is a parser, so basically it tries to interpret what exactly are you trying to tell it to do, and then it actually executes the command. So it's a pretty important piece of software because it sits between you and the computer. And the thing to remember about Bash is it doesn't hate you, but it doesn't love you either. It is completely indifferent to you, and it will do exactly what you tell it to do. Not what you want it to do, not what you thought you meant to tell it to do. It'll do exactly what you told it to do, nothing more, nothing less.
Unlike Perl.
Bash,
Literal
unlike
cheating.
Perl, which actually does actively hate you and want you to fail.
Or it tries to interpret what you're doing and try to do things where you never wanted it to.
Well, that's a little bit of this, actually. Bash does try to be helpful.
This tells you what it does what you tell it to do.
Yes.
Perl does things you don't tell it to do.
Oh, okay. Because it thought it should?
Yes.
Okay.
Do what you mean, not what you say.
Is Siri written in Perl? Bash tries to be helpful. Bash does things like globbing. So when you start, you know, we've all seen this syntax star.txt. You type that in a command line, you know, ls space star.txt. Bash is going to interpret that. That's the parser jumping in and reading this and go, all right, what does this idiot want me to do now? Oh, what does that mean? And it replaces this with all of the files in that directory that end in .txt. This is called globbing. So you can actually do wildcards here, so you don't have to type it all out, right? So that's pretty helpful. Command line completion is one of my favorite ones because I'm an absolutely horrible typist, so I type the least amount as possible. So if you start typing a command, let's say you've got a command that starts with TA, and you just type TA and hit tab a couple times, Bash will give you all the commands it knows about that start with TA, and you can start typing from there. Command history, this is just a short list, of course. Command history, you hit the up arrow in your command history, you'll see all the commands that you typed in this shell, going back by default 1,000 commands, although you can change that. I don't know how many passwords in here. It's always a possibility. There was a telnet in it. That was kind of odd, wasn't it? Supports a relatively full-featured programming environment. Now, that's a good thing Thacker isn't here. I don't think we actually have any honest-to-God programmers here, do we? Now you're all a bunch of hackers like me, sort of. Okay, so I'm not going to offend anybody by saying this. It is a pretty full-feature programming environment. Now we're not talking about compiled languages and all this other stuff, but it supports kind of the basic stuff you expect to see in a programming environment, right? Variables, loops, scope, even arrays. Ooh, you know, there's all these ways you can shoot yourself in the foot with Bash, just like in any other programming environment. The thing to remember, the best thing for me in teaching this, I've taught this a lot, and in kind of understanding the system and how you're communicating with it, one of the things that I think is really important to remember is this option right here. Every command, everything you type at a command line is going to break down into these three parts. You're going to type a command. It's going to have one or more options, and then it's going to have one or more arguments. And this may seem sort of like we're splitting hairs here, but it does make sense to understand where this stuff fits in the category, because especially if you're new to the command line, you can read some of this stuff, well, like the shell script I had a minute ago. It looks Greek. I mean, if you haven't seen this stuff, it looks like I just mashed my head on the keyboard, you know? But if you remember, and I have some shell scripts that look like that. If you remember this, you know, ls for list the contents of a directory, -l star.txt. You know, you can break all these commands down into command, option, argument. For the most part, the rule is that the command comes first, then the options, and usually, I'd love to say always, but it's usually the options are denoted by a dash in front of them, right? This is sort of the standard GNU toolkit thing. They all do this. And then arguments, what number of arguments I'm passing. So if you see a command, you see this line, and it looks like it's in Greek, you don't know what it does, try to break it down. What's the command? What are the options? What are the arguments? Of course, there are some commands that break these rules, but for the most part, this is how you interact with the shell.
Verb, adverb, noun.
Yeah, that's actually, yeah, that's pretty close. I'd say that covers most of it. Verb, adverb, noun. Yep.
Now,
Of course, when all else fails, hang your head, read the instructions.
I've done a lot.
Honestly, the man page for Bash is really good.
yeah.
It's one of the few that
It's
actually.
one of the few. It's like the second long. I think LSOF has a longer man page, but maybe Nmap. But the Bash man page is long, and it's actually really pretty good. So we're going to do a very, very, very short single slide on Linux commands I think you need to know. If you want a bigger list, I actually have a web page here. It links to a Google Doc that I maintain for my class that I teach. On commands I think you should know, kind of examples of them, whatever. You can look at that at your leisure. Here's some basic ones that we're going to see tonight in some of the shell scripting examples. Again, not an exhaustive list at all. But remember, these fit into over here. And remember, Linux follows the Unix design philosophy of number 2, small single-purpose programs. So a lot of these commands just do a few things. It's very uncommon in Linux, especially at the command line, to have a big monolithic program that does lots and lots and lots of things. The whole point of the command line is it's the Batman utility belt of tools. You're going to pull out all the different tools you want to use, you're going to chain them all together, and you make something really funky that does what you want to do, then you're going to take it apart and do something else with it. So these are all really focused on doing one or two things, doing it really well. Now, of course, there's some, there's always some bloat that creeps in, right? Emacs. But for the most part, it's small programs that do a few things and do it well. So, a few examples. Echo, simply displaying the value of a variable. Cat, sending a file to standard out. Cut, slice and dice text by columns. Grep, search for text in a file or files. Sed, the stream editor, modify text on the fly. I don't know what sort does, I can never remember. That was a joke. Unique, only shows unique items in a sorted list. And finally, TR, translates one character node. Not an exhaustive list by any means, but examples of some of the ones we're going to see. Yeah.
2 notes. 1, echo
Yeah.
may or may not be an external command.
Well, okay, that's a
Bash-
good.
Bash has
That's a
built
great.
in-
That's a great point.
It's on by default.
Bash is big enough that it actually has some commands are built into Bash. So when you type something at the command line, it may be an actual binary file that came with your distribution, live in the /bin or the /user bin directory. Or it may be something that Bash reads on the parser and says, oh, he means to do this. And Echo's a great example of that.
Yeah.
For a long time, it was a separate program. And in some distros, it is. I actually don't know if the one I'm logged into, we'll have to see. But yeah, Echo may be a Bash built in. And if you read the man page on Bash, the very top shows all of the built.
Oh, no, it's not that easy.
No,
No,
you gotta
it doesn't
search for
anymore.
built-in.
On CentOS it does.
Nope.
I
use
swear.
All caps. Several things down, so if you search for /caret built-in.
All right, fine. Nope, didn't find it. All right, anyway, there's a few.
There's one other thing I was gonna mention. I know
Yeah.
you get unique up there, it's good to use it sometimes.
Yeah,
But sort actually will do unique now.
that's right. Sort dash U, isn't it? That'll be unique.
There we go, show
Yep.
built-in.
Oh, that was the term to search for. All right.
Yeah.
You guys look at that. Okay, so that's a few commands you need. And remember, these are just commands that you would normally type at the command line or in a script, which we're going to see examples of here. And a script is nothing more than a collection of commands you would normally type at the command line, just shoved into one file and run all the way at once. So it's just a way to automate your environment. Really just like a scripting language, like your Perl, like Python, but instead of having to learn a whole new language, it's the command line tools you already know from working with your system. So if you're familiar with that at all, if you've learned, 20 different commands, your greps, your set, your awks, whatever, all you really have to do is learn a little bit of glue to chain them together, and you can be a pretty effective, you can do a lot of cool things with Linux from the command line because you know that. Now, some more of the cryptic stuff that you have to learn with regards to how Bash handles input and output. Bash has 3 different concepts of input and output, and they are codenamed standard out, standard error, and standard in. Okay, standard out is the output of a program. Usually it's your monitor. Standard in is the input of a program. Usually it's your keyboard. Standard error is where error messages go. Usually it's also your monitor. That's the default, right? But you as the admin or you as the programmer can control where these go with these symbols. So if I run a command like this, ls space -l space star.txt, I just hit enter, the output is going to go to standard out, which by default is my monitor, right? ls-l. There you go. I got one file. However, if I do this, and I use the greater than, I got away from my slide. If I use the first one here, greater than, redirect standard out to a file and overwrite if that file was there. Notice that I got no output at all. No errors, nothing. Because the output was redirected to output. I can use the cat command, which is short for, not the feline cat, it's short for concatenate. Show me the contents of the file named output. Look at that, it's exactly like it was up here. I redirected that output. If I run this again, but instead now the single greater than, I do a double. What does double mean? Redirect standard out to a file, same thing, right? But it's append now instead of overwrite. Do my cat again. There, now I have 2 lines. Okay, pretty simple.
So you can stitch stuff onto a text file that way.
That's right, you can append to a text file that way with that double greater than. Okay, let's do this. I'm going to run star.foo. It didn't find any. Now, this message actually went to standard error. But what's the default output for standard error?
Your monitor.
My screen, right? So if I do this same thing I did before and redirect this to output, hey, what the heck? It didn't redirect it. What did it redirect?
Standard out.
It redirected standard out. What's the contents of standard out?
Nothing.
Really? What is in my file? Nothing. That's right. That command generated no standard out. It generated one line of standard error, which went to my screen. What if I want to capture that? 2 greater than. These actually get assigned numbers. Standard out is officially output number 1, and standard error is officially output number 2. But this is just a shorter way of writing that. The 1 is understood. So if you don't include the 1, it's assumed that you would have typed it anyway. Sort of like a leading 0 or something, So it's assumed that you mean 1 greater than if you don't type a number. If you actually want to redirect standard error, you have to specifically say, hey, number 2, I'm redirecting that, or the double redirect error. So I can go back here and I can say 2, I still got no output because this command actually generates no output. But if I cap my output now, let's do one more. I'm going to say this. Oops, if I can spell. So look at this command. Parse it this way. Command is ls. Options -l. Arguments, in this case I have 2 arguments. Star.foo and star.text. Now remember, star asterisk .foo space asterisk .txt is not being passed to the ls command. It's got to go through bash, right? Bash is my interpreter. I'm speaking the bash language. The underlying operating system doesn't know the bash language. Bash has to do the translation, right? It's like the guys at the UN with the headphones, right? They're doing the translation all the time. Bash is going to read this, and it's going to send it through the parser. Because I'm putting stars here, it's going to go through the file globbing logic, so Bash is going to go, oh, he really means this. And it's going to replace this line with every file that ends with .foo and every file that ends in .text. So if I had, let's say I had a file called 1.foo and 2.foo and 1.text and 2.text. This line would actually get expanded out to ls space -l space 1.foo space 2.foo space 1.txt space, and then it would run.
If you want to test what the results are going to be of expression when it's blob, use echo. If you say echo star.text, it'll just put the names of the files.
Oh, that's true, because it's going to do the same thing, right? It's going to replace those with what's in the
Just gonna
file
replace
system,
those and it's
and
gonna
Echo
go back.
just spits it out back to you. That's a good point.
So that's a good way to test your
Okay, so that's going to expand to that, and then it's going to run. I am redirecting standard error to a file called output, but I'm not redirecting standard out, right? So if I run this, I get standard out now. I get my 1 line of standard out. Did this command still generate an error? It did, right? Because there isn't any star.foo. So if I cap my output, I still have that error. If I want to do them both, I can say redirect standard error to output and redirect standard out to output. I'll get no output at all on my screen. Sorry. Used to typing
And
more
you're only
instead
going to
of...
get 1 line.
And I only got 1 line. Why?
He didn't append.
You overwrote.
Because I'm overwriting, right?
Yeah.
both handles were written.
Yep. There's actually a better way to do this.
Of course there is, it's Unix.
Just because there's enough weird commands for you to remember, right? This goofy little syntax, which I didn't even put in the slide, says, whoops, actually this needs to be that then. Redirect standard out to output, and then take standard error and send it to the same place that you sent standard out. No output at all. Cap my output file. Now I get 2 lines. The thing that we struggle with as people that speak the English language working with Linux is that for the most part we're limited by the number of keys we have in the keyboard. Now of course we all have Unicode and we have extended ASCII, but nobody knows that and there's no keys for them. So for the most part, the options and the arguments, when we want to tell Bash how to do something, Bash has to know whether we're talking about data or whether we're talking about commands or options, right? So this guy, ls, that's 2 English characters, right? We're using those for a command. That's pretty easy for us to remember, list, ls, right? Can you imagine learning Unix if English was not your native language? I cannot. It's hard enough for me to remember when it is meant. -L for the long option, right? But then we've got data here. So here's an example of whoever came up, whoever wrote Bash said, okay, we got to come up with some character that normal humans can type that tells Bash to do file globbing. Well, what's the possible list they can pick from? Pretty much the ASCII character set, right? Now again, this has all kind of happened before Unicode, even before extended ASCII, so we're talking about a pretty limited set. It's pretty much what you see on the keyboard here. So that's where things like asterisk comes into play. Very seldom do you see asterisk in a file name. So it's been co-opted to mean something special to Bash. There's quite a few characters that are like that The question mark is one. It's this in file lobbing stands for anything. The question mark stands for one and only one character. There's other times when you're passing commands to the computer where you have to be aware of whether whether the character you're passing is being interpreted as that character, or if it's being interpreted as some sort of a command and control, secret code that's going to launch nuclear warheads or whatever. Because it's all dependent upon context. And that's where I think, in my opinion, where the command line really can get confusing for people is because of that fact. They'll see something somewhere and they say, oh, I know what that means. But it means something different depending upon what context they're in. So just remember that you have to sort of think like the parser does. And you have to think and say, God, okay, how is the parser going to see this? Is the parser going to know what the heck I'm talking about? Am I being clear enough here? Is it going to know what the heck I'm talking about? So we got the greater than, the double greater than. The less than, redirect standard in from a file. I'm not a huge fan of this one. And in fact, let me skip that one and talk about this last one because then it'll make a little more sense. One of the basic Unix design tenets is number 3, piping output to input. And that's this pipe character. I always wondered before this came along what the heck that character was ever used for. It's probably above your backspace key on your keyboard. Very seldom. Huh?
Below?
Oh, I meant backslash. Thank you. Very seldom do you see that key in any kind of data, right, or anything else. It's just sort of like tilde. It's sort of off on its own, right? So it's been co-opted in Unix anyway to mean send the standard out of command number 1 to command number 2 as standard in, as if you were actually typing something into standard in. This seems really simple and really basic, but man, this is like one of the fundamentals of the Unix operating system. That ability right there. This is what makes it possible to have all these commands that just do one or two things, because you can chain them all together. You can pipe them all together with this little pipe command. So I can do, fun things like, if I cat etc password, well, it scrolls off the screen because I've got a bunch of stuff in etc password, right? But if I pipe that through the command more is designed to show you text a screen at a time. I hit enter, and now I get that output, but now more is working on it. So I did the same command, cat, but that pipe command said, take my output, send it to more as input, and now more takes control. And the only limit to how many commands you can pipe it to is basically the buffer that bash has for the parser. I don't know how big it is. A lot. You can pipe and pipe and pipe and pipe and pipe and pipe and pipe. And that's really the key to shell scripting. We're going to see that here in a few minutes, is stringing all these commands together to do things that they weren't designed to do initially, but you're putting them all together with this pipe. And the fact that you can do this redirection. It's no more than this regular redirection, but instead of sending it to a file, you're sending it to standard in of another program. So knowing that, you can also do this. You can do the less than redirection, and you can say things like this. This is a perfectly valid Linux command. Cat space less than space / etc password. Now, if any of you have done command line stuff, you'll say this is a stupid use of cat, because it would be perfectly fine if we just took that out. It would just work, right? Because cat is actually designed, whoever wrote cat made it work not only with standard in, but if you pass cat an argument, it's going to assume that that's a file you want it to read. A lot of commands are like that, right? Some aren't. So, but this will say, take the contents of etc password and send it to cat as standard in. How else could we do this? No, this, you want to see redundancy. How about this? I mean, that's just stupid, right? It would totally work, though. And it would work exactly the same as this. Okay, this is, in case you haven't figured out, I'm kind of opinionated in some of the stuff. I don't like this. And the reason I don't like this is because I have to teach this stuff to people. And I don't like this because it makes me think right to left. I grew up speaking the English language. I think left to right. I read left to right. My commands I put together left to right. This breaks that. This makes me go right to left. I never ever use this. I just think it's crazy confusing. Like this crap isn't confusing enough as it is, right? I think this makes it even worse.
So that's Arabic notation.
So I never do it. Maybe if I grew up speaking Hindi, I would have a different opinion, but I never use that. But you may see it. Okay, so that's how to type basic commands on the command line, right? A little bit about file I/O redirection. We learned a few commands, not a ton. Now, let's put them together inside a script that we can then run and have them all happen at once, right? So here is the world's simplest shell script. Every programming language has to have their equivalent of Hello World. There's a great website out there, I can't remember the URL, but it's the song 99 Bottles of Beer on the Wall, implemented in about 1,000 different programming languages. It's really interesting to read how they do some of that. Some of them are recursive, some of them are full of go-tos and go-subs. This is the Hello World version of a bash shell. Now, forget this first line for a second. We could probably figure out what this guy does, right? Echo just takes a string or a variable or constant, spits it back out to you. One little thing about the quotes here, you do have to a little bit think about the bash parser here, right? You're sending data to the bash parser. It has to look at it, figure out if you're actually giving it a command or sending it data before it sends it along to the underlying operating system. So the double quotes here are one of the many ways that you can protect data from the bash parser. Think of it as you're helping it figure out what the heck you're talking about. So if you put something in double quotes, it's sort of a filter to bash to say, hey, there's no commands in this stuff. It's just data. Just deal with it as data. Don't expect to see a -L in there or something, you know, and try to interpret it. Or a star.txt, right? Actually, that's a pretty good example. You know, so if I do echo star.txt, look what happened. The parser parses my line first. And since this is a file blob, what does it replace star.txt with? It replaces it with all of the files I have in this directory that match that file blob. In this case, it's only one. Here, let's make a few more. Now I got two more. So now if I do echo star.txt, I got 3 files. Boom, 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 right? What if I do this? I'm protecting that string from the parser. So I tell the parser, hey, don't worry about this. I got it covered. I know what I'm doing. Treat it as star.text. Important to remember. Okay, so there are some situations where that's not necessary, right? If I don't have a special character in my string, it shouldn't matter. I do not have a good enough memory to remember when those cases are and when they're not. So if I'm sending something to bash that I don't want it to mess with, I just double quote it all the time, even when I don't need to. It's just safer that way. Okay, so that's the one command. Now this little...
I tried to put that exclamation point in the hello world.
Yeah, that's the key in here, because actually the exclamation point is considered a special character in certain circumstances. So it is probably good to have this double quoted here.
No, even with the double quotes in there, it breaks with the exclamation point in when I try it.
You have to echo the, or escape the
Oh, I'll be darned.
history event.
Single quote.
Oh no!
Oh.
See, remember, bash neither hates me nor loves me. It does exactly what I tell it to do.
Yes.
Or a single quote, right, Adam?
Yeah, I was gonna try. Well, I was gonna try the single quote. I was hoping that would work.
You can do a
Single
quote.
escape.
Whoops, sorry.
Yeah.
That was just a bad thing.
You can-
Now you gotta correct it.
Forget you saw any of that.
On tape.
We can, it's on tape now.
Damn it.
Apostrophe.
See, I just do that by default.
Because you can't look at your keyboard.
Bang.
There you go.
Huzzah. All right.
Now, the way to get your...
Yeah, now the question is, why is this the case? There's...
The way to get your other thing to work is no single quotes, no double quotes, backslash, exclamation mark.
Yeah, escape it.
Yeah. That's the other way.
Oh, it's so ugly. All right. A great example of how we're not going to cover all of this crap tonight. Bash has some weirdness in it. But that's very good. Yeah, that clearly doesn't work.
Well, you test everything with it.
Yeah, unit tests are important. All right, what I want to look at, though, is this first line right here. Now, in most of the, if you've done any Linux stuff before the command line, and if you've ever seen a configuration file for like Apache or Samba or DHCP or any of these, right? They may be widely different in formats, but most of them follow the convention that a line that starts with a # is a comment. Okay, that's true in bash scripts as well, sometimes, not all the time. However, this is actually a special comment line. This has to be the first line, so it has to be column number 0, line number 0. It has to start with a, what's the symbol called? Anybody?
Octothorpe.
An octothorpe. Very good, John. This is called an octothorpe. So it's actually not C sharp, they're bringing it's C octothorpe. It is.
It depends on the type of graphical construct.
Or a pound sign. I know what it's supposed to be. So we'll call it a pound sign. Okay, and the exclamation point is often referred to as a bang. So this little symbol is sometimes referred to as shebang. So shebang / bin / bash. What this says is it's telling bash what interpreter should I use to run the following commands. Now this is a little bit redundant because you're telling bash to use bash to run the following command. But a valid entry here would be /user /bin /perl or /bin /ksh for the corn shell, or tcsh or ash or zsh
Or SH.
or sh if the old school Bourne shell itself. Yes. Yes.
You talked about this once before.
Yes.
There's a very good reason to do this, because when you do this, you actually start up another instance of bash.
That's right. You start a
So if
child
if
shell.
you have a shell, if you have a script that you exit from, if you don't have that in there, it will actually exit your current shell, close your terminal.
That's right. Or change whatever variables you have in memory because it's running in your current. Right.
Yes. So in other words, it will run like a batch file if you don't have that line.
Right.
It runs more like a program or a separate instance of a
Right.
program.
That's sort of a standard Unix thing as well, that the Unix process list works on the concept of parent and child processes. So you have a parent process. When I run this now, it actually spawns a child process, runs the command, kills the child process, and then goes back to me. That's just kind of how that'll work. Comments. You can start a comment with a pound sign. You can also do this. This is pretty handy from a commenting standpoint. As soon as bash encounters a pound sign, a non-escaped or non-quoted pound sign, everything after that's a comment. So you can do comments in line like this. It can be helpful in your programming.
Why would you want to comment your program?
It should be self-documenting, right? It was hard to write, damn it, it should be hard to read too.
So if I type hash Bubba.
I want to learn it all.
I've
over
seen
again.
some hard to read bash.
I want to go back to 6 months later and go,
Yeah, I'm just
who
waiting-
wrote this?
I
Oh,
just waiting
God.
for somebody to come up with literate bash. That's what I'm waiting for. Go ahead.
All right.
Literate bash.
Some, I don't think it's going to happen. Some basic bash built-ins. Now, we're not going to cover all of these, but I wanted to give you some examples of some of them because
Isn't that Liz?
it's some stuff that you may run into, okay? Variables are pretty simple. If you've done any sort of programming, I'll just do it over here. If you've done sort of programming in the past, it's a pretty simple concept, you know, x equals 5. X had no value before, now it has a value of 5. From a syntactical standpoint, bash is very fickle with regards to how you pass it data. For example, lines that you type here. Now, these could be lines in a shell script that we run, or it could just be stuff we type at the command line. There's no difference. Lines can end in semicolons, or they can't. Bash doesn't care. If you want to string multiple commands together on one line, you can separate them with semicolons. But if they're in a shell script, line 1, line 2, line 3, line 4, whether you put a semicolon at the end or not, bash doesn't care. It's one of the few programming languages I've seen that doesn't have a definitive end-of-line character at all. It doesn't care. However, God help you if you have a space out of place, because then this won't work. This is not equivalent to that. X space equals space 5 generates an error. X equals 5 works. This, however, who cares?
The way to realize that is look at what you're saying to parser at that point.
That's right. It's all about how the parser's thinking, right?
Right.
This is assignment. This is comparison.
Or it's command
Oh,
equals
command, option, argument.
Yes, and 5 is an argument.
Oh,
That's
very
what-
good.
That's
Good
what
point.
it is.
Good point. So you have to think like the parser a little bit. X equals 5. Okay, and then if you want to see, we saw this already, right? I can just type echo X. If I do that from the command line, just echo X, I get X, right? Okay, now I'm going to give a value to X. X equals 5. Remember, whenever you type a command and you get no output back, it usually means it worked, right? No news is good news. Now if I echo X, I still get X. Because I'm not asking it to give me the value of the variable, I'm asking it to echo the constant X. If you want to even though x in this case has to be variable, if you want to reference the value of a variable, you have to put a dollar sign in front of it. Now I get 5. Another example of taking a key that we have on the keyboard that doesn't show up in data a lot. Now it does sometimes, right? If you're an accountant, you'd argue that with me. But the fact is, we have to use something to tell the parser, hey, I need a variable value. So a dollar sign was chosen.
Just for sake of fun, the vertical bar or pipe is also known as the pollen.
The what?
Pollen. P-O-L-O-N.
P-O-L-O-N.
Kind of like colon. But
There you go. I learned something new today. I have never heard that word in my
also
life.
known as the Sheffer stroke.
I'm going to go with pollen.
But the pollen sounds pretty cool.
P-O-L-O-N.
Use it in a sentence tomorrow.
That's pretty
You
good.
forgot the pollen
I
that.
forgot the pollen.
So the little bracket thing is like a substring of the what you set x as in the
Oh, the brace?
yeah.
That's next. Okay.
Oh.
This is equivalent to this. They are exactly the same. It's just a matter of how much you feel like helping out the parser today. Okay? Because, look at this example. X equals 5. Y equals 6. Echo X, echo Y. What if I want to do this?
You'll still get 65.
Oh, damn it. It always works when it shouldn't.
When you think it should.
When I think it shouldn't, is that when it works, all right? Actually, here's a much better example. I want to echo the value of y, and then the constant. Here, we'll just put foo. Now, in my head, I know that this is $y, that's a variable, and then foo is the constant. But I didn't put any delimiter between the two. How does the parser know, right? And the answer is the parser doesn't. The parser assumes that my variable name is YFOO. Well, that's not true. But if I do this, if I can tell the parser, hey, I really mean that, then I get the value of y, which is 6, and then the constant. That's the example. So, my advice is you get into the habit of putting all your variables like this. Just don't, I mean, you can mix and match, but it'll save your sanity to do it this way. And in fact,
10 years ago.
if you, what?
Where were you 10 years ago? That's a bad habit I'm going to have a hard time.
Oh, dude, I still do it, and it's been a long time.
I do it on command line.
The other nice, I can tell how long ago I wrote a shell script and whether or not I use this or not. The other nice thing about this is you have to understand the way that Bash stores strings. It actually stores strings as arrays of characters. So you can take advantage of that fact if you use this syntax. So if I say x equals f foo, here there'll be quoting when I don't need to again. And if I say echo, x, what if I do this? Now this syntax looks a little bit goofy,
Sure does.
especially when it generates an error.
Not dot, isn't it colon?
You got a dot
It's
instead of colon.
dot, colon,
No, it's colon.
sorry, it's just colon both sides. My bad. Let's try that one more time.
There you go.
Okay, what this means is, from the array x, remember x is now a 3-value array. Value 0 is f, value 1 is o, value 2 is o. Remember in computer science we start counting from 0, right? So it's 0, 1, 2. This says, show me the array x, but start at value 0 and go 1 to the right. So I get 1 letter. Start at value 0 and go 2 to the right. I get FO. So it's a really simple substring function that you can utilize, built right into Bash.
It's not kind.
If you know that, what?
The F-O.
Could have been FU, I guess. If you know that strings are stored as arrays of characters, you can take advantage of it. But it only works with this, because you have to help the parser out a little bit. That's why you'll see this. These are equivalent.
If you went one beyond the array, would it give you the syntax error?
Oh, I don't know.
Arithmetic error?
I don't think so.
Nope.
No? Okay.
And if I start from 99 and then go backwards, I just get nothing.
Okay.
Used to be you would eat garbage.
show me everything in
For-
that
for-
memory designated.
That's bounds checking. Doesn't work.
The next one is a subshell. Now we mentioned subshells a little bit with regards to parent and child processes. This is more from a parser standpoint. Remember, the parser has to read this whole thing, interpret it, and then pass it along to the underlying operating system. These are not apostrophes. This is the back tick. It should be under your tilde key, probably next to your 1 on your keyboard. It's the same character both ways. So just looking at this guy right here, x equals backtick date backtick. The first thing the parser is going to do is it's going to read that whole line, and it's going to look for the subshells. It's going to say, oh, I found one. It's going to run the command that is listed inside that subshell. If you just run the command date, you get something like this. Bash will run that command in a subshell, capture the output, and replace this entire string with the output of that command. So if I do this from the command line, x equals backtick date semicolon echo. In fact, let's just do it one at a time, okay? I got no output at all, no standard out, no standard error, nothing. So I can assume it worked. Echo x. X now has a value of date. And it's not rerunning date every time I do echo. Notice this isn't going up any, right? It ran this command, grabbed the output, stuck it in x, and x just stays there, okay? Very, very powerful tool when you're putting together your shell scripts.
Little argument slash debate is that the backticks are supposed to be deprecated.
Yeah, I know. That's another,
Because that's
I'm
what
showing my
the
age here.
glasses.
I'm showing my age here. Another, the preferred way of writing this.
Yes, is dollar sign and open parenthesis.
You know, the reason that I don't default to that one, other than I'm old and set in my ways, is parentheses are used in so many other places and have so many other meanings. I get so confused as to when I should escape a parentheses and when I shouldn't. And is this doing something else? Or So yes, this
Yeah.
actually is the same thing. And in fact, this has advantages. The primary advantage is you can nest these. You can't nest the backticks because the start and the stop are the same. So you start one and you try to nest another one, the parser goes, oh, you're ending your subshell. And you want to say, no, I'm starting another subshell. But there's no way to tell it to do that. So this is actually a much better way to do it.
The argument against it,
But I'm old.
just for anybody who's writing scripts that they're going to take multiple
Yeah.
platforms, is portability. It's not always as portable as like older AIX, HPUX.
And their version of SH, maybe.
The backtick or the
The
dollar?
dollar
The
sign.
dollar sign parentheses.
It's not supported on
That's relatively new, you know, like last
Yeah.
10 years new.
Yeah.
So yeah, on super ancient systems, it's not gonna work. A few more basic tenets. You know, every programming language has to have loops of some sort. So it's all just a matter of syntax. I think if you've been around computers a while, you probably know how some of these loops work, right? So this is a simple sequential loop for variable name in, and then you give it some sort of a list. This can be a space or a new line delimited list. In this case, it's a space delimited list. 1, 2, 3, 4, 5. And then you put the commands inside of braces in this. Now this is actually one line, right? It's saying echo number. So if I do that,
Do done.
what's that?
You can also put them in do done.
You can do that as well. So let's look at some examples here. For number in 1, 2, 3, 4, 5. Now I'm going to hit enter here. Notice something different. Bash did not run this command. It did not give me an error. But look at my prompt here. It's not my normal long prompt here. It's the greater than prompt. This is what's called the secondary prompt. This is Bash saying, all right, I got what you told me. I'm waiting for more. I'm waiting for more. You haven't finished your command yet. I'm waiting for more. So for number n, 1, 2, 3, 4, 5, I'm going to start my little loop here with a brace. I'm going to say echo $sign number, and then I'm going to close it. And as soon as I hit enter here, Bash knows from the context that I'm done. And it's going to actually do it. Okay? Simple command line loop. Now, one of the cool, go ahead.
Liner that doesn't loop.
Well, no, it does. Watch though. So look exactly what I typed here, right? For one thing, look, there's no semicolons in what I typed, right? I typed 4 lines. Now it's actually 1 line, right? But I actually typed it on 4 lines because I hit enter 4 times. There's no semicolons, right? In Bash, if I hit up arrow, I get the last command I typed back. So if I hit up arrow here, I'm going to get this command back, right? Look at the command I get compared to what I typed. Where the heck did those semicolons come from?
That's
put them in for me. Bash is trying to be helpful. Again, the semicolons only exist to help the parser know what the heck you're trying to tell it. If the parser knows, it doesn't need the semicolon. In this case, what did I give instead of semicolons? I hit the enter key. That was a pretty good indicator to the parser that I was, moving on to the next thing. But if you do it on one line, there's no enter key there. So you have to give it some sort of a delimiter where you would normally type the enter key. Bash is smart enough to put those in there for you if you're doing the command line stuff.
The slides are.
That never happens.
No, okay, no, there isn't. Okay.
No, it's not.
I thought you were missing the second semicolon.
No, that's enough.
So I got a question.
Yeah.
The first way you did it,
Yeah.
what if you screw up in your syntax?
You control C and type it all over again.
Yeah.
Actually that's not
Yep.
true. That's not true. Let's try it.
I think yeah.
Well, I'm
So I'm gonna
curious
do this.
what up arrow would give you back.
Well, I'm gonna do this, and then I hit brace, and I type blah, blah, blah. Oh, crap. I didn't mean to do that, right? I start typing up arrow here. I'm gonna get my normal command history.
That's what I was curious about.
Yeah. So it's no different than if I was from the normal prompt here.
Which actually is helpful.
Yeah. Okay, so that's for loop. If constructs, everybody's got to have an if, right? X equals 5, if. Now, this syntax, again, this is the kind of thing I think you can express in English pretty easily, right? If X is greater than 5, do this. The syntax with Bash gets a little bit goofy on the ifs. Again, it's all about how the parser handles it. That's where the semicolons come in, right? But also spacing. Spacing is a giant pain in the butt in if commands in Bash. See all these spaces here? There's a space after if, there's a space after this bracket, there's a space here, there's one here, there's one here, there isn't one here. God help you if any of those are wrong. Because it won't work. You cannot have your $sign next to your bracket. You cannot have this bracket. You can't have a space after your bracket but before your semicolon.
No touching.
Or you get no touching. You get a syntax error. X equals 5. If X is greater than 4, then echo true, else echo false. This is an example of an if, then, else construct. How do we know? Now, up here, we ended our for loop with braces, right? There's no braces here. We started our if with an if. How do we end our if loop? It's not really a loop, I know. How do we end our if construct? With the opposite of if. Fee. Fi is how you end an if construct. Now, look at this guy right here. This is a little bizarre. This actually stands for greater than, GT. This is one of the things where Bash falls a little bit short. Bash is not a strongly typed language. If you're familiar with programming, you know that types mean like, does this variable hold an integer? Is it an ASCII string? Is it a floating point variable, right? What type of variable is this?
Oh, it's strongly typed. There's only one.
Yeah, there's no, okay, it's a type less, that's actually, it's a type less language, that's right. So, if you read the man page, there's actually different comparison operators, whether you're talking about comparing strings or whether you're talking about comparing integers. And it just happens to be that the integer one got the short end of the stick, and it has the sort of the weird syntax. So instead of what we normally think of as the greater than symbol, which is greater
Already
than,
used.
right? For one thing, it's already been used. But when we're comparing integers, we have to say dash GT for greater than. There's dash LT for less than. There's dash LE for less than or equal to. There's dash NE for not equal to. So it looks a little bit goofy, but it's just when we're doing integer comparison. What if we're doing floating point comparison? Can't do it.
Yeah, I'm saying.
Bash doesn't handle floating point numbers. Can't do it.
It's all strings.
Can't do it. Do not write your accounting package in Bash. You're going to have a bad time.
Or scientific app,
How
Or,
much
yeah.
trouble would it be to write a floating point script?
Not too bad because you just have to store them all as strings.
Or we could just multiply everything by 100.
Well, or if you really, if you really had an application, there is a way to actually write extension libraries for Bash, which can be written in another language like Perl or.
But boy, you got to be a
C
Bash
or-
diehard if you're doing
Yeah,
crap like
I was
that.
gonna say,
It sounds like a
if
lot
you're
of
gonna-
trouble.
Wow.
you're gonna-
Yeah.
Yeah, don't get me wrong.
It-
I use Bash all the time because I'm not a programmer. If I were a real programmer, I would have migrated on to Perl or PHP or Ruby or whatever by now, right? But I'm not. I'm just a hacker. I hack stuff together, so I've stuck with Bash. But yes, don't try to write, the next Twitter in Bash. Not gonna happen.
Parse
Okay.
Twitter in Bash.
While loops. Maybe it is in Bash. That's why I said that. While loops. not a whole lot different than the for loop. Remember the whole idea of the for loop is that you're going to walk through this list and you're going to do something for every item in the list. The while loop, for the most part, works the same way. Instead of treating every item individually, it works on a per line basis. So in my example here, I'm catting Etsy password. There's my pipe symbol. There's my Poland. There's my Poland. My Poland is showing. And I'm typing it to while read line. So I'm saying while this happens, and what's happening is the read command, which we see right here. And then, but I'm taking the value of read and I'm assigning it to the variable lines. This is a lot of weird words, but what this basically means is inside my do and done here, inside my do and done, the variable line gets assigned the value of every line of Etsy password. So line 1, line 2, line 3, line 4, line 5. Not every item in there, like it was before, every line gets handled. Does this mouse work, John?
No, battery's dead.
No! So if I just, I'm too lazy to type. Oh, this is a PDF, I suppose I can't even copy it. All right, fine. Yeah. So if I cat Etsy password, if I just do that and hit enter, I get this. But now I'm saying, while read line, do, echo, I'll just do this. Line is line. Done. Okay, so I get every output line, and I just put line is in front of it. Again, look at that one more time. Cat Etsy password, and then I'm redirecting standard out of this guy to standard in to the while loop. While runs the read command, which just takes values from standard out and sticks it into this variable. So in between my do and done, this runs, and line just keeps getting a new value. It runs for every instance of lines in Etsy password. Another example of read just used by itself. So this would be a little shell script, 1, 2, 3 lines. Echo, enter the username, and then type read space name. This will just sit there and wait for input from the end user forever. So let's do a simple version of that. Echo type. Actually, I do need to do this in the script, huh? We'll call this foo.sh. In bash, echo type something.
Head dash n in the.
Yeah, I know. Read foo. Echo, we'll just do a simple version. You typed foo. Okay. So look at this guy. Okay. It's a whopping 4 lines. The first one is the bash line. I'm not going to go into permissions and whatever here, but in order to run this, I have to make it executable, and then I have to run it by typing /foo.sh. Notice I didn't type foo.sh, right? I typed fo and then I hit tab. Bash typed it in for me. Type something. How long is this going to wait?
How long do you want it to wait?
Forever. Forever. Until the end of time. I type something, I hit enter, you type this. Okay. Simple way to read input from standard out. Now, check this guy out though. Echo, hi there. And I pipe it to foo.sh.
Oh, snap.
I typed, hi there. Because what was it doing when it's waiting for input? It's waiting for input from standard in, right? Standard in is normally your keyboard. In this case, I changed that though. I redirected the output of this guy to standard in. So if you ever have a script that asks you, let's say there's a script that it asks you a bunch of questions. You just have to keep hitting Y, enter, Y, enter, Y, enter, Y, enter, Y, 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 right? You can subvert that by piping Y to that script. In fact, there is a command. Oh boy, there used to be. It's just yes is a thank you. If you type yes and enter, it's the infinite Y.
I think it's also broken.
Is that because of FS check?
That's the one example I can think of.
That's the one thing where it will not work.
Really?
Yeah.
Really?
If,
So
it will
something
not
like
work
that.
if it's not coming from a terminal.
Okay, whatever.
Yum also won't do that if you're trying to.
But anyway,
Oh,
that's why that works. You know, the most confusing thing for my students over the years is situations where you type something in the command line and you don't know why you're typing it in. You're just like, I know this is the syntax, I don't know what the hell it means, right? My biggest thing about Linux over the years is that it's a complicated system, but for the most part, it's not complex. Wait a minute, I said that backwards. It's complex, but it's not complicated. It's got a lot of moving parts, right? It's not the old 67 Chevy you could take the hood off of and it's got like 4 moving pieces in the engine, right? It's the newer engine, it's got all these parts, right? But for the most part, you can identify each one of them. You know how it works. You can dig in as deep as you want. You can figure it out, right? There's way too many situations in other operating systems that shall remain nameless where you're just like, I click here. Why do you do that? Because I always click here, right? And you don't know what's going on. With Linux, you can dig as deep as you want. Okay, let's start putting some of this stuff together. We know a few commands. We know a few constructs. We know how to change our flow control a little bit with whiles and fors and ifs. Okay, how is this useful in any way? Well, let's look at a few simple examples. I want an alphanumeric list of all usernames that have bash as their shell. Be a pretty common thing, right? How many people have interactive logins on my system? It's a pretty common thing I'd want to know, right? Well, let's start with the basics. Where is this data stored? It's stored in the file /password. Let's do this. If I do a head on this file, head says, give me the top, by default, what is it, 10 lines?
10.
Give me the top 10 lines of the file. Here's the top 10 lines for /password. This is a colon delimited file, variable length lines. It's got 1, 2, 3, 4, 5, 6, 1, 2, 7, is that right? 1, 2, 3, 4, 5, 6, 7 fields in it. The last field, the 7th field, being the login shell. So if I want to say, show me, my original question was, show me the usernames that have bash as their login shell. Well, let's just start with the lines, right? Let's do it a piece at a time. Show me every line in /password that represents a user that has bash as their login shell. Well, the grep command is a substring search command. You give it a substring, it'll show you every line, by default it does this, it'll show you every line that matches that substring. So if I search for grep for bin bash in, not mash, in /password, I get bash, 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 bash. I get quite a few, right? Okay. Now look at the problem with this though. Think about this. What if for some, this field right here is supposed to be like the common name of the user. In reality, the root user that creates this can put whatever they want in there, right? Theoretically, the root user could put /bin/bash in there. Now I don't know why they do it. But think about the command I just typed. What did I tell? The system did exactly what I told it to do. Give me every line that contains the string /bin/bash. That's not really what I want it to do though, is it? I want every line that ends in bin bash. You have to tell it exactly what you want. Now there's a couple ways to do that. The example I have in here is using what's called a regular expression. Now, we do not have nearly enough time for me to start talking about regular expressions tonight. That was actually an OLUG meeting, what, 6 months ago?
2010.
I got a 4-hour lesson on regular expressions. But again, it's another example of representing to the shell exactly what you want to do. It uses a syntax called regular expressions, which uses the same keys on the keyboard that we're used to, but in ways maybe you've never seen them used before. Specifically, there's some key symbols, the $ being one of them, that actually don't mean the $. In this case, the $ is what's called a positional parameter. And so this regular expression means show me every line that has the substring :/bin/bash at the end of the line. The $ in this case represents end of the line. So if I do that, $, and that's the password. There, I only get the lines that end in bin bash. Now, I didn't say in my original request that I wanted lines though, right? I wanted an alphabetic sort of usernames. Where are the usernames? It's the first column here, right? Well, one of the commands that was back on that slide a million years ago was cut. That is a command that is designed to splice up data by columns given an arbitrary delimiter. Our delimiter in this case is a colon. So, I do my same command. But now I'm going to break it down even further. This is the cool thing about the Linux command line. You start with something. I started with cat against password. I break it down a little bit. I take that output, I break it down a little bit more. I take that output, I break it down a little bit more. You keep refining. It's like a funnel. You keep going down, 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 down until you get exactly what you want. I'm going to pipe that through cut. Cut takes a couple arguments. The first one is what's my delimiter? In this case, I'm going to say my delimiter is colon. Do I have to quote that? Probably not, but I'm sick of trying to remember when I should and when I shouldn't, so I just quote everything. Field number 1. D says delimiter is colon, F is give me field number 1. Now I just get the usernames. And finally, I want it sorted. Sort. There you go. We use 3 commands. Grep, cut, and sort.
It's the only way to program.
Give it to
We
me
piped.
on one line. Call.
So what's that?
Username, comma, space, username, comma, space, username, comma, space.
Ah! TR stands for translate. Translate will translate one character to another character. /n stands for the new line. I traded all new lines for commas.
Except I didn't say comma, I said comma, space.
Oh.
Well,
Oh, that's just.
Just to make it confusing. We'll throw set in there.
No, you need to throw set and. No.
I know, to be complete, I do know. And then I got to throw an echo in there so I actually get a new line. There. There. What else you got? Come on. What else you got?
lose the last comma.
I knew somebody was going to say that.
What?
I knew somebody was going to say lose the last comma.
And the root user.
Oh, that's I can script that. Let's see. Set R, search for comma and a line. Replace with nothing.
There you go.
Oh shit! I got the echo in there. You guys think you're so smart. Oh!
What?
Search for comma.
Debug, debug.
Spam, 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 spam.
Oh, because of that. Because it's the comma doesn't end because I did the
it's
grep
comma space.
first.
So, you find
So
the last
actually,
comma space.
it would probably be easier if I just put that before then, huh? So I'm yeah.
There is no space at the end.
Yeah, there is. You can see it.
There is. You can see it.
Oh, okay.
Search. Make sure I'm doing a regular expression. Search for comma $sign replace with nothing global pipeline. There we go.
There you go.
Yeah, you start. Okay, you start throwing said stuff in there. It starts becoming less and less readable. Now, yeah, I mean, just think about this. 2 hours ago, you looked at this and go, "What in God's name does that mean?" Right? But just break it down. It's just a piece at a time, right? We're grepping for bin bash, and this is we know it's a positional. So the end of the show me every line that ends in colon bin bash and empty password. That's it. Okay. Take that and send it to cut dash d quote or colon dash f1. Pass it to cut. Hey, cut. Cut this up by colon and give me column number 1. Sort that. TR and set are complementary. They do kind of the same thing, except TR works on just individual characters. Sed works on anything. In my experience, though, and actually I could have done this with sed. In my experience, when you have these special characters, you have to do like 14 escapes to get sed realize what you're talking about. So I like TR for some of this stuff. So translate new lines to commas. Pipe that to sed and search for every line, because sed is line based. Search for every line, or go through every line and look for comma end of line and replace it with nothing. So remove the last comma. And finally, replace all the commas with comma space. And then give a final echo because I took the last new line off. It works. Yes. Is this the most what? Could I do the whole thing? Yes.
Yes,
You can
you
do the whole
could.
thing with awk. Who needs all these commands? You can do everything with awk. Now, the cool thing about this, my favorite thing about this is, no, there's no way this is the most efficient way to do this. But by God, we did it in like 20 seconds, right? And it works. And we move on to the next thing. Yeah, I could spend half a day refactoring this and writing it and assembling, but I don't want to do that. I want to move on to the next thing. I know these commands already. I'm going to string them together to make it do what I want.
Like Legos.
Like Legos.
See, what gets really nice is when you can take something like that, and obviously a little too advanced to cover here, but when you can take something like that and go across across a bunch of servers, a bunch of workstations,
Oh,
a bunch
yeah.
of machines. This double report of, you know, things you're finding on all these machines, that's really
Passing the
powerful
command
and
SSH.
useful.
Yeah, that's actually my final example here.
Well, there we go.
That's why I have a shirt that says "Go away, or I'll replace you with a small shell script."
Same public key authentication.
Okay, the next one does, I mean, pretty much the same thing. I do throw awk in there just for fun. We're not going to talk about that.
Oh, come on.
Come on. Okay, example shell scripts. All of the, this and more I have at this URL if you want to take a look at that. There's also some great guides. There's 2 of them on TLDP. TLDP is the Linux Documentation Project.org. Check these out. It's the Bash Beginner's Guide. And this one is called ADS Advanced Bash Scripting Guide. It's 10 times more than I know about Bash. It's awesome stuff. I also just a little Googling around found this. It looks pretty cool. It's a wiki that's got a bunch of good Bash guides in it. So take a look at that. Okay, that's the end of the presentation, but I want to show you one little script that I whipped up a couple months ago for fun. I had a class in here over the summer, and there were a bunch of hardware guys, and right before we talked about Bash shell scripting, I wanted to give them just a simple example of how to use the shell scripting stuff that we've been talking about to query their system for hardware information. Now, I'm sure there are probably tools out here that will do some of this stuff, you know, I don't know. My point was just to show them how easy it is to glean information out of your Linux system if you know where to look and you know a little bit about how to interactively, you know, give commands to the shell to walk through some of these things. So this has a few things in it that we did not cover in the last, you know, speedy hour here, but it is an example of how you can easily pull information out of your Linux system. Now remember, and I know it's hard to see because it's dark, we already talked about number 2 and number 3 here, right? Small single-purpose programs, piping output to input. But what's number 1? Everything's a file, right? Every command we talked about so far deals with plain ASCII text pulled out of files. Everything's a file. Everything, everything, everything. Your keyboard is a file. Your monitor is a file. Your hard disk is a file. Your main memory is a file. Now you say that doesn't make any sense. Well, it doesn't. It's represented to you, the user, as a file. Specifically,
That's the simplicity and beauty.
there's a directory called proc. If you're familiar with the output of ls-l, you'll know that you can tell what type of file this is by the indication on the very far left character. If it's a dash, it's a normal file. If it's a D, it's a directory. This then is size, 64 bytes, 11 bytes. Let's look at some, oh my God, they're all zeros and then we get hit with that one. Okay, look at this guy. 1, 2, 3, don't give it away. 1, 2, 3, 1, 2, 3, 804 million bytes, 804 meg. It's named K-Core. It's got a modification date of, right now, looks like.
Those are the permissions.
This is over here. Yeah, I'm not over there yet. This, owned by root, only readable by the root user. That's what this means. But all we really care about is the fact that it's a normal file, right? Holy cow, what is this file taking up 800 meg on my hard disk?
It happens to be the kernel.
Right. This isn't actually taking up any space on my drive. /proc, although it looks like a file system, is not actually using space on your disk. It's an example of this. Everything's a file. Proc is your kernel and your memory expressed to you as the end user through the file system metaphor. I was going to say nomenclature. I like metaphor better. It's the file system metaphor. K-Core happens to be your main memory. So, if you want to debug a running system, attach a debugger to this file. You can see every memory register change. All of these, almost all of these, are information about your system represented to you as a file. There's one, for example, called CPU info. If I do a long directory listing on that guy, I see that it's a file. It's readable by everybody. It's got a modification timer right now, and it's exactly 0 bytes in size. Well, say, what the heck good is that? It's an empty file. Well, it's not really empty. Because when I query it, this is no different than asking my system, hey, give me all the information you have about the CPU. Now, think of other operating systems that we may have used. I'm going to use Windows as the primary example, right? How do you figure out, how do you ask Windows what the gigahertz rating of your processor is? Does anybody know? Like in Windows 7?
Isn't it like the right-click manage computer?
Yeah, you go like to manage computer. It's like,
Properties on the computer.
right, it's like some little
CPU.
The point is, somebody at Microsoft had to write this little GUI app that pulled this information out of the system and displayed it to you, right? How did we get the same information? What advanced command did we just use to get the same information out of our system? More, or cat, or echo,
Less.
or ls, or less. All these commands that we know. You go to that URL I have in my slides back, commands you should know. There's like 30. If you know all of those, you can do 95% of what you need to know from the Linux command line. There's always going to be little esoteric commands, I look through, I'm like, what the heck is that? But if you know these basics, you can do most of what you need to know, because everything's a file. You learn how to work with files, you're golden. So this tells me that I have exactly one processor, and it's number 0. It is a genuine Intel, a whopping P4 2.4. They don't make them like that anymore, baby. With 512K of cache, okay?
That's a
Simple example. So let's go back to my, simple little shell script here. Stuff, Linux class, okay? So let's just walk through here line by line. I'm going to kind of gloss over a little bit, but this is on that URL if you want to take a look at it. So I have some comments here. Get the following data points about a system. So I'm going to run this. I want to be able to run this on a system, and I want to have a report back to me. How many CPUs I've got? What's the speed of the CPUs, assuming that the speed is the same? Amount of RAM in gigabytes, the name of the BIOS manufacturer, the number of hard drives, and for each physical hard drive, the size of each in a pipe delimited list. Okay? That can be pretty useful, right? If you're doing some kind of inventory on a system, or like you were saying, have this go out to 1,000 systems, run, and get all the data back, right? Could be. Yeah, pretty useful, right? I'm sure there's some commands already to do this. Whatever, that's not the point. So it just shows you how easy it is to do some of this stuff if you know a few things about what commands to run in shell scripting. So first, I'm going to create a temporary directory. Remember, this is variable equals something. Now notice here I'm using what's called a bash built-in. Bash has a number of variables that are built into it that you can access. One of them is called random. This will give me a random number between 0 and 32,767. So I use it to create temporary directories when I need it. And then I'm going to run the make dir command to create this directory. So now I have a space I can store data. I'm going to clean up after I'm done, but now I've got a space to store data. So this next whole big block right here just checks to see if I passed the option to this command. Because I'm really creating another command, right? It's going to be a shell script. It's going to be written in bash, but it's no different than ls, echo, cat, more, whatever. I can also have it accept options. So in this case, I'm checking to see if the option show header equals yes or no is passed. If it is, then honor it. Otherwise, default it's no. This is sort of a weird and heavy-handed way to do the whole option thing, but I don't care because it works. There's the header. I default my little flag here to show header equals no. I don't want to go through all this because it gets into some stuff we haven't talked about yet. There's some regular expression matching here, and there's the double bracket thing. But basically what it's doing is checking to see if I pass the option show header equals yes. If it is, then it sets this variable or flag to yes. So it's to show header yes or no. I'm going to use that later on. Okay, the meat of it is right here. Here's where I actually pull the information from the system. So let's look at this first one, CPU underscore count. egrep is not very different from regular grep. It just uses the extended regular expression library. So just think of it as the normal grep. The C option of grep says, don't show me all the lines that match, just give me a count of the lines that match. So I'm grepping for caret processor. This is another one of those examples of, remember we had the $sign before that was a positional? This is the other positional you can use, and this means the beginning of the line. So what this means in English is, give me the count of all the lines in proc CPU info that start with the word processor. So if I get out of here, and if I look at, I'm just going to cat, that was CPU info, right? This line starts with processor, and I only have one of them. So, because I only have one CPU in this guy. If I had multiple CPUs, I'd have a whole other section that started with processor down here, and it would count it as two. This only has one. So, after this line runs, where'd I go? Up here. After this line right here, CPU count, after this runs, CPU count is going to have a value, on this system anyway, of 1. Okay? CPU speed works the same way. In fact, I'm looking at the same file. But But in this case, I'm grepping for CPU megahertz, and I'm saying, hey, parse that line. It's colon delimited. Give me field number 2, sort it, unique it, and then pipe it to trim. Trim is not a command that we have talked about yet. And this tells me that the file trim is actually in user local bin on my system. If I ask the file command,
Is trim the thing you use to get rid of that last comma?
no.
Oh.
Close though. What is trim?
Bash script.
I'll be darned, it's a shell script. It's a shell script. It's got a wicked ugly looking set here that is designed to strip white space from the beginning and from the end of a string. And so I'm using, this is sort of a weird syntax. We had our ST, standard in, standard out, standard error over here, right? But remember, what's number 1? Everything's a file, right? Standard out, standard in, and standard error are also represented to you as a file. And you can access them the same way you access all the other files. In this case, I'm catting it. So I'm catting dev standard in. This makes my script work with standard input. So I can pipe something to this guy, and it takes what I piped it, and it sends it through sed, and it kicks it back out to me. So I can use it just like all my other Unix utilities. Because, what's my 4th rule? It's a little hard to see. Build your own tools. If some tool doesn't exist that you use all the time, make it. So I wanted a little thing that would cut off white space from beginning to end. I made trim. I use it. That's trim. Okay, we're going to skip through it. I think you're getting the point here. You know, mem. In this case, we're running the command free, which gives you a list of where your free memory is. You know, how portable is this? I don't know. Is this going to work if you put it on a Solaris system? Probably not. Is this going to work on a 10-year-old Debian system? I don't know. You know, that's something you have to take into account when you're doing this. I'm making a lot of assumptions here that, you know, all my CPUs are, you know, the CPU speed is going to be in proc CPU info, and it's going to start with this line. I'm making a lot of assumptions here that you have to be aware of. This one's interesting because I could have X number of hard drives in here. So I can't just query one thing and throw it in a variable, right? I got to do a loop. I got to loop through every possible hard drive. So what I do is I look in the file proc SCSI. I'm making the assumption here that my disks are being accessed through the SCSI subsystem layer. That's true if your disk is SCSI, obviously, but also if it's SATA, and actually if it's USB as well. All of those go through the SCSI emulation layer. So the kernel actually thinks they're SCSI devices. They get what are they called? LUNs. They get LUNs. They get all that stuff. If you have an old ancient system with IDE in it, this ain't gonna work. So then you need to add functionality to it. So I'm searching through this, and basically what this does is it finds all the instances of disks, and then here's that pipe while read line. So it walks through every one of those lines, and for each one of the lines, it has to go through and get the information. I'm not gonna spend the time to go through all this, but if you're interested in how this works, just kind of walk through it. You should be able to sort of figure out what all this stuff does. It's just using the commands we looked at already. Grep, echo, there's some more pipes, right? Oh, there's a set, there's a cut. Here's simple math. There's another thing we didn't look at. Another reason why I don't like that $sign parentheses for the subshell, because it's too damn close to the arithmetic one. $sign parentheses, parentheses is math. Okay, and finally, it spits it out here. So let's actually try this and see if it works.
Can I ask you a question real quick?
Yes, sir.
Why did you choose the random for the folder name rather than just using the dollar, was it $$ for the PID of the
Yeah, that's a great question. Another option you have, another built-in variable in Bash is, it's kind of confusing. The variable name itself is $. So if you want the value of that variable, it's $, $. And it actually means the process ID of your current process. You can use that as sort of the poor man's random number too. The reason I don't do that is because PIDs wrap around if the box has been running long enough. And I have had a few instances over the years where a box is running long enough that it actually overwrote a directory it wasn't supposed to because the same PID got reused. So I've started using random instead.
So you went from like a 1 in 32,000 to a 1 in...
Right, 5,000 or whatever it is. Yeah, it's a little more reliable. Now, as it turns out, I actually have to run this script as root because, which file is, one of those files I'm reading in proc. Oh, the DMI decode has to be run as root. So that's another
Hardware interaction.
non-portable situation with this script. So I just run HW info by itself, and it says I've got one processor. It's a whopping 2,394 megahertz. I have 0 gigabytes of RAM. You round it down. The BIOS manufacturer is Dell Computer Corporation. I have 2 hard drives, and they are 320 gig and 320 gig. If I do the remember the header thing? Dash dash show. I could have made that shorter. Header equals yes. Then I get a header on top of it. Okay, nothing that a million other tools out there probably don't do. That's not the point. I mean, the point is, I whipped this up one morning in like 20 minutes. You know, not really knowing anything. I knew I had to. You know, I was like, oh wow, DMI decode. What does that do? Oh, look at that. And there it is. You know, just to prove the point that if you know a dozen of these tools, you don't have to be an expert. There's 1,000 commands out there. Don't learn them all. Learn like 40 of them. Learn a few of the basic constructs we saw in that shell scripting. If, you know, read the Bash Guide to Beginners. You know, I mean, by all means, learn a programming language. I mean, don't get me wrong. But this sort of stuff is just use it and throw it away. I can't tell you how many times I just type these out on the command line and one-liners. Get my answer, take it, go. And I didn't bother saving it. You know, and then when I come across it again, do it again. Yeah, it gets a little complicated. I save it somewhere, but
I'm of the opinion that if you learn 10% of interacting with Bash and do this kind of thing, you can improve your productivity by about 30%.
oh, absolutely, right? Get it all down to text. I've been doing a lot of stuff with MySQL lately and pulling data out of database and doing all this stuff. And there are quite a few times, I'm not a SQL expert by any means, quite a few times where I'm just like, okay, I'm gonna use the command line and I'm gonna hit the MySQL database. I'm gonna pull this data out and I'm gonna use these tools to parse it. Because I'm faster with grep and sed and awk and cut and echo and all these. And then it's done. And I move on to the next thing. So yeah, again, you're not gonna write, you know, your next big e-commerce app in Bash. But it is a productivity tool. You could totally do it. I actually saw a CGI calendar program that was written in the corn shell years ago.
The only thing
It's a prototype though.
It absolutely is, right? Again, it's the Lego methodology again. You know, build quick, does it work? Great. Moving right along. It's got to run 1,000% faster on 100 machines. Here, you do it in C. You know, but it works.
I'll give you another thing. One of the things I end up doing is a lot of times I'll write little 10, 15 line scripts. I keep them.
Yeah.
Keep them all tossed in a directory. Next time if I need something else, I'll say, oh, I did something like that. Let me grab my scripts for whatever I did.
There you go.
Copy one of them, make changes, and use it.
There you go. Great
Easy to
example.
use.
If you want to make that more complex,
Yeah. Oh, please, please do, John. Let's make it more complex.
Now, he's not a C programmer.
well, no, he can do this.
Oh, I
with,
wish Aaron
he
was
can
here
do
for
this
that.
with grep. The fact if the HT is turned on for the processor,
Yeah.
it will throw your processor report off by a fact.
What is HT?
Hyperthreading.
Oh.
That's the virtual processor. So
Right.
if you do have a quad core with hyperthreading, it'll say you have 8.
That's right. It'll report double because you got 2 cores or 4 cores. It's counting number of cores, not number of processors.
Yeah,
So that's
Pipes.
valid. You
It's
could just say
pipelines, yeah.
you could just say this script is counting number of cores instead of number of processors.
Yeah, I was gonna say if you look at the CPU info, it'll actually tell you the core count
Yeah.
instead, which will tell you irregardless of how many fiber threads are on it.
So we saw some funky examples of some weird cryptic crap you can pass to sed. This is a pretty cool program. This is a great script that I reference more often than I probably should, called sed one-liners, that just has a ton of great examples of, it's like a sed cookbook. And the only reason I sort of hesitate to do this is I don't know what 90% of these even mean, but they work. I don't have any idea why in God's name this triple space is a file. I don't even know where to start with that one, but it works.
How about just G double spacing?
Okay, what, semicolon G? What does that even mean? I cannot parse sed at all.
Double
But
space.
boy, there is some good copy and paste stuff in here, baby.
Double space.
Where do you think I got that
all the way.
trim syntax? I didn't come up with that myself. So there's some great stuff in here. How do you do all these weird things?
I
with
could have
sed?
sworn there was already a trim command though.
Yeah.
Well, I'm thinking of L trim and R trim.
Oh, there you go.
Okay.
That's SQL. Add commas, numbers with decimal points and minus signs. That's pretty darn useful, right? Look at that horrible syntax. My God. That's 3 back references.
That's sad, man.
I know. It's awesome. But it hates you. Said actively hates you. Don't let anyone tell you different. It actively hates you.
It's all on the
It's
stream.
super cool.
It's all on the stream, baby.
It's on the screen.
Can't
So,
stop the stream.
learn use the stream. Learn a few
Going
things.
across the streams.
You don't need to become an expert to get a lot of functionality to increase your productivity greatly on some of this stuff. It's a lot of fun. I love just whipping them out real quick, just moving on to the next thing. Right? Get it down to text. If you can get your data set down to plain text, then whatever. I mean, there's 100 commands you can use to monkey with it. Go crazy. And you start learning some of these things, especially like the regular expression stuff. That can seem daunting at first, but then remember that regex is built into things like VI and Apache and grep, and all these tools support regular expressions. So if you learn that, you can use it. You're reading a man page, you can do regular expression searches in your man page.
Yeah.
That's good. You totally can. Because it's less. Because less is preferred.
Less is good than more.
Less.
Yeah, more or less.
Less is the new more.
Yeah, but if you're old like I am.
You just type
You're
more all the
stuck
time.
on
Me
one.
too. I can't get away. I typed it way too
Actually, I
many
like
times.
most.
It's like they teach you in kindergarten.
Most?
A lot is a lot.
If you
The
really
Todd is
Jet
alive.
text editor, Judy gave us this text editor.
Yeah, Jed.
Their version of less is most.
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 All right. So if you really want to learn this stuff and you're having trouble sleeping at night, go to.
You having trouble staying awake?
So that's what I meant. It'll put you right to sleep. So that HW info is right there. And I got a bunch of other goofy ones too. So the extract email address is kind of cool. It's a regex that'll, you throw any blob of text, it will just pull the email address out and show you one per line. I actually use that quite a bit. So, all right, that's all. You've been a very attentive and helpful audience. Thank you. An interactive audience. I'll turn it back over to Mr. Larson.
Back to the
Unlike
URL
Michelle.
page.
Unlike Michelle, you don't actively hate me. What's that?
Back to the URLs list.
Oh, yeah.
Slide.
Oh, I keep forgetting that mouse this morning. That was this one, right?
Yeah.
Yep.
Comes the lights.
LDP, it's the LDP.org. That's good stuff. And John will have this up on the OLUG site momentarily.
Actually,
When will the stream?
we should have the lights. Stream's technically up.
Well, it's not.
What?
Oh no. It didn't record.
No, it's
Oh, I gotta do it all again?
It could be the flash.
Yeah.
I've seen it happen.
What was
before.
that?
These are the commands that I think you should know.
Jay was in the chat
How
room.
many do I have? I do
That's
have
what
all.
Scala is
How
for.
many do I have?
Pearl of hackers.
That's what's.
No, that's more than 30, dude.
You're right. I have 53 because there's 2 header lines. I have 53 commands that you should know.
About rooting my nook.
Oh, he's not here. He never came over from the bar.
He's still in the bar.
Is he still over there?
I know it's streaming.
He's still sitting in the bar.
There's 5 people. Now there's 3 people
Well,
still
maybe I'll
watching.
just-
So.
Email the list.
That's a good idea.
DU.
Yeah, some pretty
What's that?
single-use stuff.
Viewer.
Okay, we're always looking for more topics, so you don't have to listen to me or poor John every month. So, anybody got anything they either really want to know about or are willing to stand up here and lie about for an hour and a half?
I've been on that a couple times.
Yes, I know. It's all right. It's not a punch card. You don't get 10.
Actually,
one free.
I
after
was
you use 10
I was
hours.
actually watching some of yours earlier today.
Oh, all messed
I'm
up.
clearly not giving John enough to do at work.
No, I moved all the Ustream stuff into YouTube because our Ustream account was getting full.
Ah,
They only give you 10 gig.
okay.
Misers.
Plus, most people tend to search for things on YouTube anyway. So
They only give you 10 gig.
yeah,
They put
unless
more
you
than
buy
that on
the
this
pro
thing
account
here.
for $100 a month.
I can put more than 10
Whoa.
gig on this
What?
thing.
$100
without
a
only,
month.
like,
That's a
$100
little.
month.
That's kind of a
On
big
my
jump
back
from
end.
But
0 to
they
100.
remove the ads.
$100 a year,
and stuff
maybe.
like that.
Wow.
But ad block will do that too. You want to remove the ads. So.
I know.
October, November, December, 3 months left of the year. So I'm sure in December we'll do the little Christmas thing again. We'll have some people bring some things in. They try to do some short talks and kind of socialize for that event.
The Heartland Developers Conference is going on
That's right.
the actual conference is this Thursday and Friday at the La Vista Conference Center. It's sponsored by Phenom Blue, Joe Olson at Phenom Blue. He's run it for years, pretty much single-handedly. They're doing a new thing this year. Wednesday, the day before the actual conference, they have a number of half-day sessions. One of them is an introduction to the Arduino, and I know John and I are going to that, so I'm pretty excited about that. But if you're interested in doing that, I'm pretty sure there's still spots available. So I think it's hdcomaha.com, or just search for Heartland Developers Conference. You'll find it.
When is
Are they
that?
really?
Yeah.
Oh wow. I knew for the half-day sessions they are.
Oh, okay.
Not for the actual Thursday, Friday conference though. They're not. And it's a great. I mean, you know, it's obviously pretty programmer specific, but it's a great conference. They got some good stuff.
They got mobile app development.
Mhm.
Yeah.
There's some good
Stuff
talks.
like that.
And when is that?
It's this Thursday and Friday. This week.
Embassy Suites, La Vista.
Yeah, the La Vista Conference Center. You going to that?
It's the worst week.
Yeah. I know. But it's like, when's a good week, you know? That's the
Yeah.
problem.
This one's a particular.
Why is this one particularly bad?
I have to go through and,
Oh, just something. I thought you were gonna say like there's 4 other conferences going on or something.
no, I mean, as
Oh,
far
okay.
as work goes from.
Yeah. Yeah, it's always tough to find a good spot.
You wanna go?
Does that mean you're gonna do a talk on your Arduino?
No.
when you learn
Oh,
something
I would love to. Yeah. Yeah. Sure.
The Omaha Maker Group
What is
guys
the-
may have already done that.
Yeah, talk about that. Does everybody know about the Omaha Maker Group?
One of the people was here for the GNU radio.
Yeah.
That they were doing some filming, so they came in to listen to Aaron's GNU radio stuff.
Cool.
So,
I've been to the Maker, it's pretty cool.
Where is it?
Peter Kiewit Institute?
Oh, it's in PKI. Oh, okay.
No, they moved.
Oh, they did.
They currently rent,
they have a makerspace.
yeah, they now have a makerspace and it's pretty neat.
I think there's a TARDIS there.
What? I don't know.
I saw the blue box in one of the videos.
All right.
Sweet.
They
Well, they have
also
a
got
webpage somewhere.
Hackaday.
What is that?
They got on Hackaday.
Oh, they got on Hackaday.
Oh,
Oh, okay.
really?
They were mentioned on Hackaday.
Yeah.
That's pretty
Uh,
I
cool.
believe they have webcams.
Yes, they do.
In their space that you can see what's going on inside. Meaning to get over there sometime.
Where are they at?
We have not decided that. I'll let you know. Somebody look it up.
I don't remember where they are.
I don't know.
It's bad. We're on video saying that too.
It's all right. We don't know.
Probably check the Tech Omaha website. Probably should have something about that.
They use Search Omaha.
It's on their website, so.
It's there. That's true. Okay. Well, if you want to come next door for the after party thing, you certainly are welcome to. I know you have to go, so
I could go to home.
I'm still have jet lag from my trip to Seattle. So
I started grad school.
I'm living in the West Coast.
I started
time
grad
zone.
school. I know. It's a FaceTime. It's a FaceTime. I gotta go to home.
What are you thinking?
Yeah, something to do. I didn't have enough fun.
Well, thanks everybody. I'm gonna say that so I can stop the video. I gotta give it a few seconds, and then I gotta press stop.
In, what's it called? Global knowledge and data mining in their computer science department. So I'm taking that. A lot of database stuff.
That's cool.
It's pretty fun. But I had to learn how to study all over again. So.
It's hard to know.
I know.
Especially if you end up with an instructor who is younger than you, you'll want to punch them in the throat.
I'm just coming to terms with the fact that all the kids in the class